Hello everyone. Topic in this video is round robin RR process scheduling algorithm. Okay, so let's discuss it. So in selection criteria in this algorithm is each selected process is assigned a time interval which is known as a time slice, or I can say time quantum. So basically in this algorithm particular time is selected. For that time particular process is allocated to the CPU. For example, you can use particular device for maximum 4 hours. Okay, for example, you can use your laptop for maximum 4 hours. If you have completed your work within the 4 hours, then it's good. But if you can't complete that particular your task, whatever you are working on, if it is not completed, then after that you have to wait until you get your turn, just like that. Okay, so that particular time slice is selected in this algorithm. Process is allowed to run only for this time interval only. Okay, for example, process cannot if there is just one unit remaining to complete its process, then even in that case also process needs to be preempted to the queue, and it will wait in the ready state until its turn come. So there are two things that can be possible. The first, process is either blocked or terminated before the time quantum has elapsed. So it may be possible, for example, if we say time quantum is 10 unit and process burst time is just 5 unit. So is that possible that process is terminated or a block before the time quantum has elapsed? Okay, so in this case CPU switching is done and another process is scheduled to run. But if it's not completed, then process needs CPU burst longer than the time quantum. For example, particular process needs 12 unit, okay, and your time quantum is 10. So after first execution, there are two unit that is remaining for its completion. Okay, so in that case process is running at the end of the time quantum, and it will be switched and it will wait there to get the CPU again. Now it will be preempted and moved to the end of the queue. So CPU will be allocated to another process, and here the length of time quantum is critical to determine. You have to be very critical whenever you are deciding your time quantum. Why? Because if you take short time quantum, that let's say 1 unit, okay, then process switching it will be more. And if you have refer the topic of process switching, okay, then you are very well aware about how much time it takes for process to switch. Okay, operating system needs to save the status of recent process, load the process, next running process, like that. Okay, so and if you take long time quantum, then also it is not good. It will be if you take long time quantum, then directly it will become FCFS, first come first serve process. Okay, for example, if I say time quantum is 20 and there is no any process longer than 20 unit, so what will happen? Process that arrive in that order, it will be selected just like that, so it will become FCFS. And what are the disadvantage of FCFS? It will be disadvantage of round robin in particular case, that is long time quantum. So decision mode, when time quantum is over or a process completes its execution, it starts a new job. Okay, whatever is earlier. Selection of a new job is as per FCFS scheduling algorithm. Now let's see implementation. This strategy can be implemented by using circular FIFO queue. So in FCFS basically we are just taking single FIFO queue. Okay, but it is a circular. If any process comes or process releases CPU or process is preempted, it is moved to the end of the queue. Okay, When CPU become a free, process from the first position in the queue is selected to run. Now let's see one example so that you can get a very clear-cut idea of how round robin works. So over here processes are given with their arrival time and with their burst time. Now if you want to perform this scheduling on the base of round robin, you need at least one parameter, that is time quantum. Okay, that is time quantum. And in some cases context switch time is also mentioned. For example, you can see time quantum is mentioned with 4 millisecond and context switch overhead. As I have said earlier, switching also takes some time, okay, in which your CPU is idle. Okay, so that particular time is given with 1 millisecond. And what is your time quantum? Your time quantum is 4 milliseconds. So what does it mean? It means that particular process can execute it can be run till maximum 4 millisecond. Okay, so at a process, this particular process P0 arrive at T0, and as you know this process is implemented using circular FCFS. So whatever come first, it will be served first, but maximum up to 4 millisecond. Okay, so you just need to check how many units it requires. P0 requires 10 unit. It requires 10 unit. Okay, so this process P0 will be executed till 4 unit only, not 10 as in case of first FCFS. Why 4? Because time quantum is specified with 4 millisecond. That's why. Okay, so time quantum is completed. Now what to do? There is nothing you can do. Okay, because this is the how round robin works. So obviously this process P0 goes to the last position of the queue and next process will be selected. So what, and you can see over here I have mentioned the remaining time of processes. Okay, so over here till now from 0 to 4, how many processes has arrived? So you have process P1 and P2. Okay, process P1 and P2. P1 arrives at 3 and P2 arrives at 3. Right now you are at 4. That means this particular process does not exist at a time. Okay, so P1 has a 16 unit to run, 6 unit to run, and P2 has 2 unit to run. Okay, so you can see remaining time of process P1 is 6, P2 is 2. Now as you can see process P0, it's get switching, so again it comes to the last of the queue. This is your queue actually. Okay, so in this queue P0 it was first selected, after that P1 comes, after that P2 comes, and again P0 context switch will happen and P0 comes over here. Now process P1 will be selected, but this particular overhead is required to calculate and to represent in Gantt chart because it is mentioned over here. You can see context switch overhead is 1 millisecond. So 4 to 5, that is the time which is spent in context switching of the processes. Okay, so after 5 process P1 will be executed and it requires 6 time of unit. Okay, so up to 5 to 9 this process will be allocated and the queue will be like this. Okay, so after P1 there is process P2, and you can see from the previous case P0 it will be in the queue which has remaining time of 6 unit. Why 6? Because 10 minus 4, that is 6. Okay, after that process P3, okay, which has arrived at time 5, that's why it is in queue. Now once this process P1 completes its 4 unit, okay, this process is not completed yet because it has 2 unit to complete. That's why it comes to the last position of the queue with remaining time of 2. Okay, so P1 is executed. Now process P2, it will get its turn, but before that 9 to 10 it is the context switching overhead, so that is idle. After that process P2, now you can see process P2 just required 2 units to execute. Okay, so this process is completed just in 2 units. Okay, from 10 to 11, 11 to 12. Okay, it will not last long to the 4 unit because it only required 2 units to execute. That's why it will be terminated at 12. So this process P2 is completed over here. So now what are the remaining processes? That is process P0 with 6 unit, process P3 with 4 unit, and process P1 with 2 unit. Okay, so which process will be selected? P0, because it's his turn, it's turn. So from 12 to 13, this is idle, that is context switching time. Okay, so 13 to 17 process P0 will be selected, and you can see process P0 has executed till from 0 to 4, this 4 plus this 4, total 8 unit has been finished. So how many remaining of process P0? That is 2. It requires total 10. So over here you have executed 4 plus 4, that is 2 is required. Now after that P3 will be selected. Now this queue is very important to maintain. If you do mistake while maintaining the queue, that means you are finished in this calculation. Okay, so you need to be very careful. So from 17 to 18, that is context switch, that is process switching time. Okay, and after 18 process P3 will be selected, and it requires 4 unit. Okay, 4 unit, that is 18 to 19, 19 to 20, 20 to 21, 22. Okay, so process P3 is completed, and okay, process P3 has been completed, and now you have total 2 processes, P1 and P0. Okay, so 22 to 23 is idle, P1 with 2 unit, so 24, 25. After that you have only process P0 with its remaining 2 unit, so 25 to 26 is idle, and process P0, it will execute it till the 2 unit. Okay, so this is how round robin works. You are just performing round-wise execution of the processes, but you just need to care about this time quantum. Okay, you can only execute the process till the time unit. You have limited amount of time. Okay, once time slice is completed, process CPU will be switched to another process. That is the scenario. Now finish type of process T1, you can see process P1 P0, it completes at 28, that's why it is 28. Now it is very easy from the Gantt chart. You can see process P1 completes at 25. Okay, process P2 completes at 12, process P3 completes at 22. Now let's see turnaround time, T1 minus T0. Okay, so turnaround T80 for P0, that is 28. Okay, after that for process P1 it is 24. Why? Because 25 minus 1. Okay, after that 12 minus 3, that is 9. After that 22 minus 5, and you got your T80. After that it's waiting time. We can see in round robin scheduling waiting time is more. Why? Because over here context switching is performed frequently, that's why. Okay, so waiting time for process P0, you can see how many times process finished over here at 28, and how many units it spent in waiting. So you can see from 4 to 13, from 4 to 13 it is waiting. After that from 17 to 26 it is waiting. Okay, so you can see 28 minus 10, so total 18 unit it spent in waiting time. Okay, after that process P1 also wait for 18 units. TAT is 24 minus 6. Okay, so 18. After that, process P2, 9 minus 2. You can see process P2, which arrived at 3. Okay, which arrives at 3 and gets CPU at 10. So this 7 unit plus, okay, 7 unit, that's all. From 2 to 10, from 3 to 10, that is its waiting time, that is why it's 7. Okay, after that, process P3 is completed at 22, and when it's arrived at 5. Okay, so 22 minus 5, that is, okay, what is waiting time? Okay, at 18 it comes at it gets its CPU for the first time at 18. So 18 minus 5, that is 13, or you can use this formula also, TAT minus delta T, that is 17 minus 4, and you got your answer, that is 13. And you can calculate average turnaround time, okay, like this, and average waiting time. After that, let's calculate advantage of round robin algorithm. So it is simplest, fairest, and most widely used algorithm. Now disadvantages is context switch overhead is more compared to other algorithm. Determination of time quantum is too critical, because if you select short time, then context switch is more compared to other algorithm, and if you choose large time quantum, then it will become FCFS. That's why. If it is too short, it will cause a frequent context switching and lower the CPU efficiency. If it is too long, it causes poor response for short interactive processes. So that's all about round robin scheduling algorithm. Bye bye.